The images on the right are analytical tools, diagrammatic flow maps of different parts of Owens Lake. There's a fundamental assumption here that when we draw these vectors and hatches, they represent something. Often abstracted based on colors, pixel alignments, and apparent textures, in reality those are concrete flows. To be more specific, those are the effects of concrete flows. Flows of water, flows of wind, flows of chemical nutrients, flows of salt, and their visible effects on the landscape via flows of light. A direct implication here is that an architectural intervention might engage with those flows. If we manipulate the wind, water, and chemicals on the site, we can transform the landscape. And if we manipulate flows of light on the landscape, we can transform how people see it. The governance of these flows has defined the history of Owens Lake and will define its future. These are satellite images of Owens Lake from the last 30 years, presented non-linearly. To present them linearly would be to suggest an unfolding, an orderly sequence. In reality, the lake bed has been shaped and reshaped by a series of nonlinear, aggressive interventions. The chief protagonist here is the Los Angeles Department of Water and Power, humans. LADWP has been performing a continuous attempt to control the particulate content of the air at Owens Lake and beyond. They found success in this task by transforming the soil, water, and wind on Owens Lake. As they switch to a stable management phase of the project, their objectives have shifted. Now that particulate concentrations are low, LADWP has shifted its focus to reducing its consumption of energy and water. Their primary strategy for doing this covers more of the lake in vegetation. As the BACM, best available control measure, that requires the lowest input of energy and water, while providing, in LADWP's words, the most aesthetic value, managed vegetation plays a critical role in future planning. One obstacle to covering more of the lake bed with vegetation is the difficulty, in certain environmental conditions, of propagation of saltgrass and other potential ground cover plants. While they study a list of 45 species that are being evaluated for their ground cover potential, LADWP has adopted a strategy of sod relocation. A viable strategy in the short term, LADWP would benefit in the long term by having a fuller understanding of the conditions in which saltgrass and their 45 other test species can thrive. This project proposes a test BACM, highly managed vegetation. The geometry of the plan is largely defined by the coordinating of water inputs and the tillage patterns formed by repeated tractor passes. A demonstration testbed in the south invites visitors to walk around and explore different plant types, and an entrance to the middle of the polygon brings people across the mixing station and into an elevated viewing platform. To the north, an LADWP lot serves as a maintenance hub for their managed vegetation project. The groundscape of the polygon is a tillage and managed vegetation hybrid, with separate inputs for high and low salinity water. The managed flow and mixing of water allow LADWP to mediate aqueous salinity as well as soil moisture and salinity levels. Together, the topography of the polygon and the mediated inputs yield a sort of gradient zone, wherein soil hydration and salinity are gradually modulated. The transects above show how different plants might thrive in different zones of this loosely managed groundscape. Water and salt flows are considered in plan. This section engages wind. The long section modulates the prevalent northerly winds using compression and release to define zones of higher and lower wind speed, thereby establishing different growing environments across the polygon. The primary zones of human occupation on either end are defined by low wind speeds. The northwest elevation looks to coastal seawalls for functional and formal precedent. It cuts down ground level winds inside and outside the wall while allowing for a continuity of landscape across the lightly differentiated interior-exterior condition. The simultaneously curved and stepped surface dampens wind entering the building, while tractor-sized doors allow LADWP to manage and till the polygon as necessary. Infrastructural elements and qualities, the seawall, the roll-up door, are formally composed so as to unsettle immediate legibility as either infrastructure or architecture. This ambiguity is established in a specific configuration of infrastructural elements that is perceptible in the closed view and is heightened from afar, where typologies of repetition, scale, and sheet metal are belied by locally and functionally specific form and apparent non-uniformity. There's a representational proposition here. Any image that can plausibly be believed to engage with realism in its depiction of the on-the-ground, factual condition of a landscape should, in keeping with its stance vis-a-vis the real, not be still. Traditional landscape photography presents static images. To portray the landscape as a static entity is to mislead. Non-static photographs that portray the landscape as a system in flux ask the viewer to recalibrate both their understanding of the landscape and, in the Anthropocene, their agency relative to it. The internet-connected world understands extreme, dangerous, and at-risk landscapes, mountain ranges, the North Pole, Owens Lake, via satellite images. Understanding designers' role as public-facing image shapers, to ignore the satellite image is to ignore the part of the building with the most potential agency in regards to public understanding of a site. The images we see here are the effect of highly processed and manipulated light and data captured by a satellite called Worldview 2 at a resolution of 31 centimeters per pixel. Treating flows of light and data with the same attitude it takes towards wind, water, and salt, this project enacts a direct engagement with satellite imagery via its roofscape. The translucency of a low reflectivity ETFE roof gives the aerial viewer a muddled image of the ground beneath it. Defined by a photovoltaic frit pattern that operates at the pixel scale of 31 centimeters, the roofscape is a satellite resolution version of the landscape it covers. To the satellite, and so for the satellite viewer, the distinction between roof and landscape doesn't exist. This ambivalence reflects our own. How do we understand the landscape?